Chris here from the Oracle Mobile Platform team. Welcome to this Oracle Mobile Cloud Service video where we're going to look at configuring an Oracle Jet hybrid mobile app for push notifications using MCS for both iOS and Android. We've got a lot to cover in this video. So before we look at the actual configuration, let's first recap how push notifications on mobile devices actually work. And this will help you understand the work we're about to undertake in the overall video. From previous videos on push notifications, you'll know that each mobile platform, including Android and iOS, had their own cloud-based push notification services that you must use for their mobile platform. So for Android, in the past, this was referred to as Google Cloud Messaging, or GCM, and has now been melded into Google's Fire-based Cloud Messaging, or FCM for short. Equivalent on iOS is Apple's Push Notification Service, or APNS. Now, in order to use these services, you as the mobile developer first must manually sign up with each vendor's services via their web consoles and obtain required artifacts for developing with their platform and using push notifications. As such, from Apple, you'll end up with things like a development certificate, provisioning files, and P12 files. From Google, you'll receive API keys and a project number, also referred to as a sender ID. And we'll go through how you get these from each mobile vendor more in a moment. Having obtained these artifacts, you then configure your mobile app with them as required by each platform. So this will be different for Android and iOS based on whatever the vendor solution requires. Now remember, we're writing an Oracle Jet application though, which is predominantly written in HTML, CSS, and JavaScript, and runs with Cordova on a mobile device. So we're not writing a native Objective-C or Swift application for iOS or Java's equivalent on Android. With this in mind, JavaScript out of the box doesn't have native support for push notifications. In turn, Cordova itself has no out-of-the-box support for push notifications either. Rather, we must rely on a third-party Cordova plugin to provide the push notification capabilities. Whichever Cordova push notification plugin we choose, we will configure it with push notification artifacts from each vendor we've received when signing up for their service. And we will also add code when the application is started that the app, when it would be running in iOS Android, will register to receive push notifications from the specific push notification service, be it APNS or GCM FCM. Now, how this works in your app, is it makes a call to the Cordova plugin that then makes a call to the operating system to register for push notifications on the device. On the app's behalf, the operating system then registers with the push notification service for the specific platform your app is running on, that being APNS for iOS and GCM FCM for Android. Via registration with the vendor's push notification service, the vendor will then return a token to the app unique to the app on that device. The app must then submit that token to a server to store for later use. And in terms of these videos, that server is Oracle Mobile Cloud Service. And we'll talk more about what its role is in a moment. So with the push notification registration out of the way, the app and the user then go on their merry way and do whatever they need to do. However, at some arbitrary later point, you will want to send a push notification to that user of your app. And this is where Oracle Mobile Cloud Service comes in. It will be responsible for allowing you to create and relay messages to the devices via the vendor push services. Now, from an MCS perspective, you must first configure it to know about the credentials required for sending messages to GCM, FCM, or APNS. And again, this is what we're going to teach you how to do in this video. Then MCS provides you a screen to raise messages and target mobile devices that previously were registered with MCS during the registration process. In doing so, MCS will look up the associated registration tokens, then send to GCM and FCM for Android or APNS for iOS the message and the token. Finally, GCM, FCM, or APNS will then relay the message to the specific mobile app on your user's device, and the push notification will be displayed showing the message that you sent. As you can see, there's quite a lot going on behind the scenes for push notifications, especially as we're building an application not just for one platform, but two. Now, of course, it's the purpose of this video to show you all those steps for both iOS and Android. Now, before we kick off showing you all these steps, I am assuming you know the basics of creating a hybrid mobile jet application. And this includes installing all the required software, which not only includes Oracle Jet, but it also includes the the Android SDK and Xcode. Of course, you know that while the Android SDK is available on Windows, macOS and Linux, Apple's Xcode is only available on macOS. So to get the iOS part of this video working, you need a Mac. Now, if you're not familiar with all these steps required, can I suggest you check out these two articles which take you through the setup in detail. Then in addition, for Xcode on your Mac, you must also run the following two commands on the command line: Xcode select install and npm install at the global level iOS deploy. Alternatively, for the Android SDK, you must also install via the SDK manager the additional tools: Android Support Library, Android Support Repository, Google Play Services, and the Google Repository. Right, so with the prerequisite software installs out of the way, in this video I'm now going to show you the steps for how to create your Oracle Jet hybrid mobile app, manually register your app with each vendor and also register for push notifications, configure your app with any artifacts from the vendor, test the app to ensure you have the basic scaffold setup working, load and configure the third-party Cordova push notification plugin, add the code required for the Cordova plugin, then configure MCS with the required artifacts for push notifications, and finally send notifications via MCS and test they appear in the application. Now, in saying these 8 steps, and it does seem like a lot, we're going to have to do this for both iOS and Android. So in reality, we have 8 times 2 for a total of 16 steps to perform. And obviously, the more mobile platforms we add to our Jet application, the more work we have to do. Whew. Alrighty, so let's roll up our sleeves. Well, I would if I was actually wearing a shirt with sleeves today, but let's roll up our sleeves and start from the very beginning. Let's create our Oracle Jet hybrid mobile application. Now for this video, as we're creating a Jet app to run on both Android and iOS, as the Jet tooling requires for iOS actually Xcode to be installed, and Xcode is only available on a macOS, I'm going to undertake all the work on a Mac which has Xcode installed and also the Android SDK. So on the macOS command line, we're going to create a Jet hybrid mobile app that supports both iOS and Android. So what we first do is we call Yeoman to create our application scaffold via the yo command, and then we want to create a Oracle Jet hybrid app, and we'll set the source directory as my Jet app, and we'll use the basic Jet template. Now importantly, we need to list the platforms this app will support, comma delimited. So for this video, it will be iOS, comma Android. Next is the app ID, which takes the typical reverse URL notation plus your app name separated by dots, and must uniquely identify your application. So we're going to use com.acme.myjetapp. The app ID will be shared across the running iOS and Android applications, and in Android it's also called the application ID, while in iOS this equates to the iOS bundle ID. Next, we'll supply a human readable name for the app too, and we're going to call this exactly the same as previous, my Jet app. So I'm pressing return with Yeoman or yo. We'll then create the app source code scaffold, and we'll have to wait a while, but once done, we can cd into the my Jet app directory. Now at this point, I always like to test the app just to make sure everything is working okay. Now for iOS, we would typically test our applications on the iOS simulator. However, unlike the Android emulator, which does support push notifications, the iOS simulator does not, which is honestly a major pain in the butt. Now as a result, we need to set up the Jet app to deploy to a real iOS device. Now this in turn is a pain in the butt, as we can't just deploy our app to our iPhone unlike Android, as iOS requires the app be correctly signed with a certificate. Alright, so what does Apple actually want us to do then? Well, what we need to do as developers is sign up for a developer or enterprise account with Apple's Developer Center. In addition, I mentioned earlier, we also need to sign up for Apple's push notification services. Now, also as a bit of a pain in the butt, unfortunately I can't show you how to do this on the Apple Developer Center, as Apple's terms and conditions preclude me from recording their website for training purposes. So instead, what I'll do here is cover off at a high level what you need to create so you get the general idea. So, from Apple's Developer Center via your developer or enterprise account, you need to create for your application a provisioning profile, and this provisioning profile must be enabled for push notifications. You in turn must create an application, a development or distributed certificate. Note that the certificate's bundle ID must match the app ID we supplied when we created the Oracle Jet application earlier, which you will remember was com.acme.myjetapp. Now, once created from the Developer Center, you will download then install the certificate CERF file into your keychain on your Mac by simply double-clicking the CERF file, then entering your admin password. So here on my Mac, you can see the specific certificate I've loaded into the keychain. In turn, you then download the provisioning profile and install this into Xcode by simply double-clicking it. To see this installed, you open Xcode, then Preferences, then Register, then select your Apple developer account, then the associated team, which for a single developer account will only include yourself. Next, select the View Details button, and under the Provisioning Profile section, you should be able to identify the provisioning profile you just installed. Note you can actually right-click on this and select Show in Finder, which shows the files located under the Users directory, your Mac account name, library, mobile device, provisioning profiles. Keep that file handy, we'll have to use it in a moment. Taking a step back, it's a combination of these two files that will allow us to actually install an iOS app on an actual iOS device. There's also one other task in the Apple Developer Center required for MCS later. You'll need to create, separate to the application certificate used to install the app to a real device, you'll need to create an Apple push notification service that is an APNS certificate as a P12 file, optionally password protected, and download that to your developer PC too. Now the certificate, which we will upload in MCS later, will allow MCS to send push notifications to APNS to relay to the device and the application. So as a recap, we need a provisioning profile for the application, an application certificate, and an APNS push notification certificate as a P12 file. With all of this in place, we can now return to our Oracle Jet application. Having installed the certificate and provisioning profile locally, we then need to return to our Jet app and make it aware of these. To do this, we create a Cordova build config.json file within the project, and within this file we add details about the provisioning profile as follows. As you'll note, I've added provisioning profile for both debugging and a production release of the app. Now typically you would have different details for each of these. One maps to your development provisioning profile and another to your distribution provisioning profile. But I'm going to cheat for purposes of this video and I'll reuse the same provisioning profile details for both debug and release. For the provisioning profile entry, we need to return to Xcode where we had identified, then right-click the provisioning profile, then Show in Finder. For the file shown, if we open this in a text editor and we identify the UUID key and resulting string, we then copy and paste this value, this string, without the tags into the provisioning profile entry. In addition, we then locate within the file the key team identifier. We copy that string without the tags into the development team option. You then leave the code sign identity hard-coded to iPhone distribution, and finally you set the package type. Now for me this is set to Enterprise because I'm an Oracle Enterprise developer. For you it might be set to Development, to App Store or something else. With regarding to all these options, all the build config.json options are explained in the following Cordova page if you want to learn more about what the different options mean. Right, having made all these changes, we can save the file, then finally return to the command line and test our app in iOS. To do this, we call grunt serve, specifying the platform as iOS. We then include the build config.json file. And finally, our destination is a real device. Now you can't see this here, but my iPhone is connected to my Mac via USB. Pressing return, this will then kick off the application build, then we'll attempt to deploy the application to my iPhone. Now unfortunately, there is a current bug with Cordova's build mechanism, which Jet relies on for iOS deploy, which may result in the application being built but deployment failing, as you can see here. Now the actual issue can be found via this URL so you can keep track of it. As a result, until Cordova fixes this, you'll need to sideload the application onto your device via a third-party Mac application like iFunbox. So here in iFunbox on my Mac, I locate the built IPA file, For the application, under my Applications home directory, Hybrid, Platforms, iOS, Build Device. Double clicking on this will now load the app onto my iPhone. To see the result of this, I'm now here projecting my iPhone screen to my Mac and recording the output so you can see the app running. Now, when we tap on it, first of all, you're likely to get this error message saying that the certificate used for the app is not trusted. To solve this, you go to Settings, General, Device Management, then you select the certificate of the same name, then Trust. And finally, returning to the app, hooray, it's finally running. Wow, I feel burnt out already. You would think it would be a lot easier than this. Apple really doesn't make this easy. Anyway, alrighty, with iOS out of the way, we've tested it, what do we have to do from an Android perspective? Now, in a similar fashion, we do need to register with Google's developer service, both our application and for the requirements of push notification services. Now, push notifications on Android has become somewhat a little confusing recently, as Google is transitioning its push notification platform from Google Cloud Messaging, GCM, to Firebase Cloud Messaging, commonly abbreviated to FCM. Now, what you need to keep in mind though is the FCM service is really just GCM wrapped in a different web console. As Google is transitioning customers from GCM to FCM though, I do recommend you start looking at using FCM, as I suspect we'll find Google will drop the older GCM web console soon. Now, like Apple's push notification servers, we need to set up GCM to receive notifications. So let me show you how to do that. So personally, I already have my own Google account, which I've accessed the Firebase web console at http console.firebase.google.com. Now in the console, I'm going to create a brand new project, my Jet app. Then I select Add Firebase to your Android app. I enter our app ID, com.acme.mygetapp. Then I complete the rest of the steps. And while doing so, when prompted, we then open the Google Services.json file. Now within the Google Services JSON file, note the project number. This is also referred to as the sender ID, and we will need this for our Jet app in a minute. So write this down. So then close the file and then complete the wizard. Once the new project is created, we then select the Projects menu and Settings option. Next, we click on the Cloud Messaging tab. And finally, on the page that's revealed, we copy the server key, also known as the application key, as we will need this later for MCS2. Right, now we're set up for FCM. So now we return to the Jet tooling to deploy the app to Android. And unlike iOS, the Android emulator can test push notifications, so we shall find deployment much easier. On the command line via the Jet tooling, we can call grunt serve, specify the platform, which is Android in this case, then the destination. My ABD here equates to the emulator virtual device I've configured earlier in the SDK manager. Note at this stage we don't require a build config JSON file, as we're not creating a production release version of the application with certificates, which is required for Android. iOS requires more because we were actually deploying to a device. Having done this, eventually the Android emulator will open and eventually we can see our app. Now, as you know, the Android emulator is notoriously slow, so I have to speed up the video here to save you having to wait around while the emulator starts. But that's it for Android. It's much simpler to test our app than iOS, that is for sure. Great, so at this point we've got a running Jet mobile app that can be tested on a real iOS device or the Android emulator. That's an important baseline, so we know the apps at very minimum can be deployed and run, and more importantly be tested. But what's next? So out of the box, Jet mobile apps themselves do not have any capabilities to work with push notifications. Rather, Jet delegates that responsibility to Apache Cordova that is coupled with Jet hybrid mobile apps. However, Apache Cordova at the time this video was created itself does not support push notifications out of the box. It delegates that to third-party plugins to provide this capability. As such, you need to identify and install a third-party Apache Cordova plugin to provide this capability. Now, Cordova plugins come and go, but at the time this video was created, a popular choice is PhoneGap Plugin Push, available under an MIT license free of charge, and you can see its documentation at this URL. In order to install this plugin via the install page and iOS subsection, we can see the plugin requires Xcode 8 or greater installed, which we'll assume you've already installed. And the plugin also requires CocoaPods installed. CocoaPods is a dependency manager for Swift and Objective-C projects. To install CocoaPods on your Mac, first issue the following command line: sudo gem install CocoaPods. And when prompted, enter your admin password. Once done, next we need to update the local CocoaPods repository by issuing pod setup. When that completes, we're now in a position to add the PhoneGap Plugin Push plugin to our Jet application. To do this, we ensure we're in the My Jet app directory, CDing into it if we need be, and then we CD to the hybrid directory. Then we issue the Cordova command, Cordova plugin add PhoneGap-plugin-push. And this will download the plugin and adds the necessary libraries to support push notifications in our Jet hybrid mobile application. While we're here, we also want to install the device Cordova plugin, which we'll use later in this video by typing Cordova plugin add Cordova plugin device. Now, unfortunately, at the time this video was created, the Cordova device plugin introduces a bug when deploying iOS applications that the app gets stuck at the splash screen. To get around this, we need to locate our main index.html page in our app, and within the header section, update the content security policy meta tag from default source star to include self-gap ready file star. Having made these changes from here, we need to add the code to call the plugin library at runtime. Now remember, we have two goals: to allow the app to register for push notifications as well as receive any sent notifications. So we will use the push plugin to support both these scenarios now. To do this, in our app, I'll add a simple Jet button component to the base index page to kick off the registration logic. And the click handler function in JavaScript behind the scenes where the registration logic will lie. Now the first bit of code we'll add is code to instantiate the plugin's push notification library via a call to the init function. This takes an object containing the various outputs for configuring the service for the different platforms. As you can see here, I've included settings for Android, including a sender ID that requires the project number we recorded earlier from FCM. So I'll copy that in now. Alternatively, iOS requires a different setup, including that a push notification will raise an alert, a badge, and play a sound. Now, if you'd like to learn more about the initialize options, visit the push notification plugins documentation pages on the same. Now, as you've likely also noticed, before calling the init function, I actually checked to see if the push notification has already been instantiated, ensuring the push notification object is only instantiated once, regardless of how many times our user eagerly clicks the button for this code. From there, we need to configure code to handle three explicit events the push notification service will raise for us. That is, registration event, a notification event, and an error event. Now, this is facilitated by using the push to on method that allows us to define a callback function to add our own logic for all three events. The call to push to on the registration event forces the push notification plugin to call Apple's APNS or Google's FCM to register the app for push notifications. The callback functionality you supply is then called, which includes the payload returned from APNS or FCM, which of critical importance includes the token. You can extract this via a call to data.registrationID. Now, after this, we need to add our call to register the token with MCS, but we'll come back to that in a moment. The notification event and associated callback handler is called when APNS or FCM sends the device a push notification message to display. The data payloads includes various items, including the message, the title, message count, sound, image, and any additional data as part of the payload. As such, you could display the push notification message via a simple alert, among other options. Finally, the error event and associated callback is for any errors detected by the push notification plugin. Here too, we could add output, or we could output the message via a simple alert too. So by configuring the push notification plugin in our app, it now has capabilities to register for push notifications and receive notifications as well. However, what we still have to achieve is when the app registers for push notifications and receives the token back from APNS or FCM, we need to submit that token to MCS. In turn, later, when we use MCS to send notifications to our app, as MCS is to relay these messages through APNS or FCM, we need to teach it how to do this too. So let's look into how to configure both these steps. For registration, before we can submit the token from the app to MCS, we need to configure MCS so it knows about our app and its iOS and Android settings. So in MCS, I will create a new mobile backend. Having created the mobile backend, note the various settings including the mobile backend ID, anonymous key, and base URL. We can write all these down as we will need all of these for our Jet app in a moment. Next, I will create two clients under the mobile backend to represent the iOS and Android instances of our Jet application. So we'll start with iOS first. Here I'm entering a client display name and a name, and then of course select iOS as the platform and enter a version number to represent our app. For the bundle ID, this must be the app ID we supplied when we created the app and matches that in the provisioning profile from the Apple Developer Center as we discussed earlier. Having created the client, MCS will give us an application key, and again we need to write this down as we'll be using this in a moment. Having created the iOS client, we then add a profile. The profile allows us to say the client will support Apple's push notification services. There we need to upload the P12 certificate we downloaded from the Apple Developer Center earlier. On doing all this, MCS will validate the certificate, and on pressing create, we've then configured MCS as far as we need to for the iOS side. Now let's take care of the Android client registration. In the MCS UI for the mobile backend, we'll again select client and add a new client, this time creating a client for Android. Once created, we'll copy down the Android application key. Next, we will then create a profile. Now note the options here say for Google Cloud Messaging, but this will also work for Firebase Cloud Messaging. We'll leave the default XMPP selected, then enter the API key and sender ID, which was the project number we copied down when we registered for FCM earlier. Once done, we save all our work. So at this point in creating the MCS mobile backend, as well as the client and profile settings, MCS now knows about our app and can receive notification registrations and also send messages. However, to complete the picture, we must now teach our app how to actually register for push notifications with MCS. To do this, MCS provides the MCS Cordova SDK with libraries to make this a simple function call. To add the Cordova SDK to our app, we covered this in an earlier video, which you can again review here. Overall though, the basic steps are to download the Cordova SDK and unzip it. We then copy the mcs.js file into our Jet app source.js directory. Then in the source.js main.js file, within the required JS config path option, we add the new MCS library. We then create under the JS directory a new file called mcsconfig.js with the following code. Within that file, we copy across the contents of the Oracle Mobile Cloud config.js file from the SDK into the MCS config.js file we just created. Within the copy code, it's here we copy all the settings for the Jet app to call MCS via the MCS SDK JavaScript library we've just copied in. So in this demo, we're only going to use HTTP basic authentication for any calls from our app to MCS. So I'm going to cut out the options for OAuth, Facebook Auth, SSO Auth, and Token Auth. In turn, there are options for Sync and Sync Express, also not used in this video, so I'll cut them out too. From there, we copy in all the values I told you to write down from MCS, which includes the mobile backend name, base URL, backend ID, and anonymous token. We also need to copy in the application key from the clients. However, MCS gave us two application keys, one for iOS and one for Android. To facilitate this, rather than hard coding the application key, we'll make it derived from a variable of the same name. For that variable, we'll use the Cordova device plugin we installed earlier at runtime to determine if we're running on iOS or Android, then to dynamically provide different application keys based on the results. Finally, within the MCS config function, we'll then add code to initialize the SDK. Then in the main.js file, we must also add the MCS config JavaScript file that we just created to the required JS modules and add it to the dependencies of the main module. Having configured the setup of the MCS SDK, we can now return to the push notification registration task. So in the push notification registration push on method, after the registration has occurred with APNS or FCM, we add the following MCS call to MCS to register the return registration ID token to MCS as well. As you can see, the method includes success and failure callbacks. Now, for purposes of demonstration, I've added alerts to show the outputs of these methods. Though in a real application, you'd be unlikely to show anything to the user on success, and possibly on failure, you'd write something to the logs, not the screen. Finally, before we can call this method, MCS requires a user either logs into MCS anonymously or with their credentials. Now for demo purposes, what I'll do is I'll add a login button to our page. Then in the code behind the scenes, I'll add this. Here you can see I'm logging in with a hard-coded user. Of course, in a real app, you'll build a login form, but this code is suitable for demo purposes. If the login is successful, we will see an alert to tell us the user has logged in successfully. Otherwise, we'll see a failed login message. Okay, having done all this, we're now finally in a position to test what we've done. To test this, I'll run my Android app in the Android emulator and simultaneously run the iOS app on my device, but record its screen here so you can see what happens. Now, for each app, we first need to log in. And when we do this, oh, it's failed. Okay, so there's something we missed. If we open the debugger, we can see in the background that the application is hitting a cause error. So we need to add the running app's IP address to MCS's security allow origin policy. When the Cordova app runs on Android, this is 10.0.2.2 port 8000. And for iOS, this is 127.0.0.1 port 8000. So to do this, we log into the MCS UI, open the administrations page, download the policy file, open it, and change the security allow origin policy to HTTP 10.0.2.2 port 8000, comma, HTTP 127.0.0.1 port 8000. So on save, I'll then upload the file to MCS. Then once uploaded, we're good to go again. So back to the apps. And we'll try the login again. And this time we see success on both platforms. Next, we will log into the MCS UI, open the mobile backend and go to the notifications page. This page is designed to allow us to send push notifications, and we'll use it in a moment. However, it also gives us access via the Manage Devices button to see all the devices that are currently registered with the mobile backend, which there are none. as we haven't run our app with the new MCS code yet. So with the app running on both iOS and Android, we'll now click the register button. After a moment or two, we'll see the app successfully registered with MCS for push notifications. If we return to the MCS UI and Manage Devices screen, on pressing refresh, we can see our app is now registered, twice, once for iOS and once for Android. A special note the user who registered as well as the notification token. This is what originally came from APNS and GCM/FCM on the respective devices. Right, if we close the screen and now send a highly inspirational message, on sending the message and returning to the devices, if we wait a second or two, we can see the notification being raised via our code on both apps. That is iOS and Android. Now, if you're rubbing some sweat off your brow, I don't blame you. There was a lot of work to do there. There's quite a lot of configuration work required to get all this running, but that's because our Jet app is not just running on one platform with one push notification server, it's running on multiple push notification platforms and multiple mobile solutions. So of course, the more solutions or mobile platforms we support, the more work we have to do. But overall, you can now see how we got all of this working. A lot of work, but quite satisfying at the end. Hope you found this video useful. Hope to see you in the next MCS video soon.